It begins as a ripple in the void, not a sound, not a light, but a distortion. A place where space bends so far inward that even the concept of direction seems to dissolve. Against the backdrop of an infinite black canvas, the black hole's event horizon hangs like the edge of a cosmic cathedral, its vast invisible walls shaped not from stone or steel, but from the very fabric of reality itself. There is no door, no arch, and yet it is a gateway, the most dangerous threshold in the universe. Around it, light twists into impossible arcs, spiraling into an endless whirlpool. Stars, once fixed and steady, smear into rainbows of gravitational lensing, their ancient light stretched and bent into shapes no human eye was meant to see. Space itself seems to lean toward it, as if drawn by some irresistible gravity of meaning, not just mass. The black hole does not shine. It steals shine from everything else, yet it is surrounded by a halo of fire, matter heated to 1,000,000 degrees in its final frantic spiral before vanishing forever. The mind resists the idea that this place could even exist. We are taught that everything has a boundary, that crossing a line means stepping from one state into another. But this boundary, the event horizon, is different. Here, crossing does not mean passing into a new place. It means surrendering to a law of nature that even light cannot escape. It is not death in the traditional sense. It is erasure, the annihilation of location, of time, of any concept that can be mapped or measured. And yet there is beauty here. The kind of beauty that terrifies because it is indifferent. The kind that demands you look deeper, even though you know you shouldn't. The kind that whispers questions you cannot unhear. What lies beyond this edge? Is it oblivion or something else entirely? The vastness before you suggests a truth far stranger than either. Physicists tell us that if you were to hover at the threshold, you would see the universe accelerate before your eyes, stars being born, dying, and dissolving into darkness in the blink of a moment. 1,000,000,000 years of cosmic history passing in a breath. For the rest of the universe, you are gone. For you, the fall has just begun. But there are anomalies, things that defy even our best theories. Strange mathematical whispers in the equations of general relativity. Oddities in the way black holes emit energy. Patterns in simulations that resemble symmetry, order, even design. As if deep inside, something structured exists, something that doesn't belong in a place defined by chaos. The camera of imagination drifts closer. The halo of superheated matter blurs into streaks of molten gold. Gravitational waves hum at frequencies no human ear could detect. The horizon looms, not like a wall, but like a lens, curving everything behind it into a sphere of distorted light. Crossing it feels less like falling and more like being pulled into a hidden dimension, a place where geometry itself has different rules. For centuries, black holes have been framed as the ultimate cosmic dead ends, tombs for matter and energy, swallowing everything without a trace. But in recent years, an unsettling possibility has emerged that they might not be tombs at all. That the singularity at their center, the infinitely dense point at which our mathematics break, could be more than just a collapse. That it might, impossibly, be a form of structure. A lattice of spacetime so alien in shape and purpose that the closest human analogy would be architecture. Architecture inside a black hole. The thought alone feels absurd, the way dreams feel absurd upon waking. And yet the numbers suggest patterns. The theories hint at form. The whispers from quantum physics hint that the inside of a singularity may not be a place at all, but a design. If true, then the event horizon isn't just a wall. It is a doorway into an alien geometry, a shape that exists beyond the limits of human perception, where angles do not sum to 180 degrees, where parallel lines might meet, and where the shortest distance between 2 points is neither straight nor curved, but something else entirely. And if such geometry exists inside a black hole, who or what placed it there? Could this be the fingerprint of an intelligence beyond time? A remnant of the universe before our own? Or something that was always here, waiting for life to evolve enough to even notice? The universe offers no clear answer. Only the deep cold hum of gravity and the slow dance of light across the horizon's edge. The black hole watches without eyes, waits without purpose, or perhaps with a purpose so far beyond our comprehension that to glimpse it fully would drive us mad. At this threshold, fear and wonder are the same thing. Every instinct says to turn away. Every fragment of curiosity says to step forward. You cannot have both. You must choose. And somewhere deep in that darkness, the answer, or something pretending to be one, waits. The camera pulls back, showing the black hole from a distance once more, suspended in the star-speckled void. It does not move, yet it feels as though it is leaning toward us, as though it is inviting us in. For now, we remain on the outside. But the question has been planted, and it will not leave. What could be hidden in the heart of a black hole? And why does it feel like it's been waiting for us to ask? Long before a black hole becomes a doorway, it begins as a grave. The death of a massive star is not quiet. It is a cataclysm so violent that space and time themselves seem to recoil. Imagine a sun dozens of times larger than ours, a blazing titan that has burned for millions of years, suddenly reaching the end of its fuel. Deep within its heart, the fusion fires sputter and fade, and without the outward push of that energy, gravity wins. The star begins to collapse. In seconds, its core implodes, compressing matter with unstoppable force. Temperatures surge to hundreds of millions of degrees, atoms are torn apart, and the very nuclei of elements are smashed together in a final, furious act of creation. Heavy metals, gold, platinum, uranium, are forged in these fleeting instants, scattered into the galaxy by the violence to come. Then comes the blast. A supernova erupts, releasing more energy in a few seconds than our sun will emit in its entire lifetime. The shockwave tears the star apart, flinging its outer layers across space in a brilliant halo of gas and dust. The light of the explosion can outshine an entire galaxy, visible from millions of light-years away. For nearby worlds, if they exist, it is a death sentence. For distant observers, it is a cosmic spectacle. But at the center, something else happens. If the collapsing core is massive enough, no force in the universe can stop its inward plunge. Not the resistance of atoms. Not the push of nuclear forces. Not even the quantum rules that forbid certain particles from sharing the same space. All are crushed under the sheer inevitability of gravity's pull. In that collapse, the core shrinks past the size of a planet, past the size of a city, past the size of an atom, and keeps going. The mass of millions of Earths is packed into a point so small that it defies comprehension. Space is no longer a stage on which events happen, it is the event. Time itself bends inward. The singularity is born. Around it, the leftover material forms an accretion disk, a vast, swirling ring of gas, dust, and shattered stellar remnants spiraling toward oblivion. Friction within this maelstrom generates heat beyond imagining, igniting the disk into a luminous whirlpool visible across the universe. Matter falls in, releasing bursts of energy in the form of X-rays and gamma rays, the death cries of a doomed star. But the strange thing about black holes is that they are not just destroyers. In their violence, they help shape galaxies. The jets of high-energy particles they sometimes unleash can trigger the birth of new stars. The material they capture but do not consume can enrich the interstellar medium with elements vital to life. They are paradoxically both executioner and gardener. And yet, for all we understand about their birth, the heart of a black hole remains shrouded in mystery. Even as the stars' remains vanish beyond the event horizon, we are left with an enigma. Where does the matter go? What becomes of the space and time-swallowed whole? The equations of Einstein's general relativity lead us to the singularity, a point of infinite density and zero volume, but physics breaks there. It is a blind spot in our understanding, a cliff edge beyond which no current theory can see. Some physicists argue that the singularity is not truly a point, but a place where our models fail, a placeholder for deeper laws we have yet to discover. Others suggest that what forms inside may be more than a collapse. It may be the creation of a hidden structure, a geometry alien to our three-dimensional intuition. If so, the violent birth of a black hole is not just an ending, but an opening. The idea is intoxicating and unsettling in equal measure. It reframes every black hole not as a dead remnant, but as a potential seed, perhaps of another universe, perhaps of a structure designed to last longer than any star. If such seeds exist, who or what planted them? Are they natural consequences of cosmic evolution, or tools built by an intelligence older than galaxies? In the death throes of a massive star, we may be watching the construction of something unimaginable. A singularity is more than destruction, it is transformation. And the violence that creates it may be only the prelude to a far stranger story. For now, all we see is the surface, the luminous accretion disk, the jets, the gravitational pull that bends light itself. The true birth cry of a black hole is silent to us, hidden beyond that horizon. And yet, just as an archaeologist can sense the outline of a buried city without ever seeing its stones, scientists are beginning to suspect that what lies inside may have form, symmetry, and intent. The black hole's beginning is not a quiet event, but neither is it the full truth. The real mystery begins only after the last fragment of the star crosses the horizon. Once it does, we have no direct way to look inside, only the strange hints left in the math and in the patterns of the universe itself. And in those patterns, some say, lies the first clue to the alien geometry hidden within. It began not in the depths of space, but in the quiet solitude of Albert Einstein's mind. In 1915, he completed his general theory of relativity, an audacious reimagining of the universe, where gravity was not a force pulling objects together, but the bending of spacetime itself. In his equations, mass told space how to curve, and space told mass how to move. It was beautiful, it was elegant, and it was dangerous. Einstein's mathematics was like an open door, and others soon walked through. In 1916, the German physicist Karl Schwarzschild, calculating from the trenches of World War I, solved Einstein's field equations for the case of a single, perfectly spherical mass. His result was clean, precise, and horrifying. It suggested that, under certain conditions, spacetime could collapse into a point of infinite density, what we now call a singularity. Einstein himself resisted the idea. Infinity was a red flag, a sign that the theory had reached its limits. Surely, he thought, nature would find a way to avoid such monstrosities. But the math did not care about comfort. It was relentless. For decades, most physicists shared Einstein's skepticism. Singularities were considered curiosities, mathematical mirages that would vanish once we understood the full complexity of stars. The idea of a point where the known laws of physics failed felt too extreme to be real. Then, in the 1960s, new discoveries began to erode that certainty. Quasars, unimaginably bright beacons from the far reaches of the universe, were observed, and their energy output could only be explained by matter falling into something incredibly compact. Theorists like Roger Penrose and Stephen Hawking proved that, under realistic conditions, collapsing matter didn't just approach a singularity, it had no choice but to form one. The singularity was no longer a ghost in the equations. It was inevitable. But inside that inevitability lay something far stranger than anyone expected. Schwarzschild's original solution described a perfectly static black hole, but other solutions emerged, ones that spun, ones that charged, ones that hinted at inner horizons and regions of spacetime folded in impossible ways. Some of these mathematical interiors were not chaotic voids, but places with structure. And here, the whispers began. A handful of theorists noticed that the mathematics could allow shapes inside a singularity, patterns of curvature that repeated like tessellations in higher dimensions. These weren't random distortions. They had symmetry, order, and in some interpretations, almost architectural elegance. The problem was that such features existed in a realm we could never see. The event horizon sealed them off forever. The only way to know they were there was to trust the equations, to let the math paint a picture of something no human would ever directly witness. But trusting the math meant accepting its implications, and those implications were unsettling. If the inside of a black hole had shape, if it followed rules of geometry beyond our own, then perhaps it was not simply the end state of matter. Perhaps it was the beginning of something else. Einstein's field equations, in their purest form, were indifferent. They did not distinguish between a universe made by chance and one made with intent. They merely described how matter and spacetime intertwined. But if those equations were showing us a recurring pattern, a hidden geometry present in every singularity, then we might be looking not just at a quirk of physics, but at the blueprint of an alien design. The phrase alien geometry sounds like the language of science fiction, but mathematically, it is simply geometry that cannot exist in our three familiar dimensions. It can still have rules, still have harmony. It is just harmony of a kind we cannot visualize without bending our own thinking into shapes as strange as the spacetime it describes. And so the question shifted. It was no longer do singularities exist? That battle was over. The new question was, what is their true nature? Are they chaotic endpoints of destruction, or are they the most intricate structures in the universe, hidden behind the perfect disguise of nothingness? This is where science treads into dangerous territory, where speculation begins to blur with philosophy. Because if the geometry inside a singularity is ordered, if it is a kind of structure, then perhaps it serves a function. And if it serves a function, then perhaps it was meant to. Einstein, were he alive, might have dismissed the leap from mathematics to meaning. Or perhaps, staring into the impossible curves of his own equations, he would have felt the same shiver that modern physicists do, the sense that something is hiding there, just beyond the reach of certainty. The blackboard is filled with symbols, but behind the symbols is a shape. And behind the shape, perhaps, a mind. It began, as many unsettling discoveries do, in the margins, not in a peer-reviewed journal but on a digital image passed quietly between researchers. At first glance, it looked like a work of abstract art, intersecting curves, repeating arcs, and patterns that seemed to spiral inward toward infinity. But the labeling told another story. The lines were not arbitrary, they were coordinates. The file was said to originate from a computer simulation of a rotating black hole, a Kerr black hole, run on a supercomputer as part of a high-gravity modeling project. Such simulations are common, designed to test how matter behaves near an event horizon. But this one had been different. The physicist who leaked it claimed that, deep in the calculations, the model produced something it was not programmed to create, a recurring geometric shape in the black hole's inner structure. At first, it was dismissed as a numerical artifact, a glitch in the simulation. But then a second independent run reproduced the same pattern. And a third. The coordinates described something real, at least within the mathematical framework of general relativity and quantum corrections. The shape was symmetrical in ways no chaotic collapse should be. It was precise, deliberate. The image was nicknamed the map, though in truth, it was more like a floor plan. It showed regions inside the black hole arranged as if along corridors of warped spacetime, each section mirroring the other in a fractal-like repetition. In classical theory, there should be no rooms or corridors inside a singularity. Everything should collapse into a point of infinite density. But here, the geometry resisted collapse, forming a stable pattern within the calculations. If it were only one group's result, it could be ignored. But whispers began to spread among astrophysicists. Similar structures had quietly emerged in other black hole models, some buried in datasets no one had fully analyzed before. It was as though the simulations had been trying to tell us something for years, and only now were we looking closely enough to notice. Officially, no one claimed it was anything more than a quirk of the math. Unofficially, the speculation grew bolder. Was this a natural, self-organizing property of extreme gravity and quantum fields? Or was it, impossibly, evidence of design? The idea of design was the most dangerous. Because if the pattern was intentional, it implied a designer, one capable of manipulating spacetime on a scale beyond our imagination. This was no simple engineering feat, this was cosmic architecture. And that meant the black hole was not just a grave, but perhaps a machine. The leaked map began circulating in the fringes of the scientific community. Some dismissed it outright. Others were intrigued but cautious, unwilling to jeopardize their careers on something so speculative. A few, however, dove in, attempting to reconstruct the geometry using pure mathematics rather than simulations. Their results were startling. The same shapes emerged, consistent with equations that accounted for both general relativity and quantum effects. And then came the strangest development of all. An astrophysicist analyzing gravitational wave data from black hole mergers found faint, unexpected oscillations in the signal, ripples that, when plotted, bore uncanny resemblance to one of the structures in the map. It was not proof, but it was a coincidence too perfect to ignore. The official explanation was simple: noise. Random fluctuations in the detectors. But once you've seen the map, it's hard to unsee it. The oscillations looked deliberate, like a fingerprint pressed into the fabric of spacetime. Some theorists began calling it the blueprint. To them, the map was not just a representation of a black hole's internal structure. It was a plan. Perhaps for stabilizing the singularity. Perhaps for using it as a gateway. Perhaps for something no human mind could yet grasp. The danger of such an idea is obvious. If a black hole's geometry can be manipulated, if the interior can be shaped, then it might be possible to build with them. And if it's possible, then perhaps it's already been done. That would mean these maps are not just the result of physics, but the signature of an ancient construction project written into the deepest recesses of the cosmos. The deeper you look at the lines and curves, the more they seem to hint at purpose. The symmetry is too perfect, the ratios too precise. The structure folds back on itself in a way that echoes patterns found in certain crystal lattices and in the mathematics of biological growth. It is as though the black hole contains, in miniature, the same logic that governs life. Skeptics argue that the human mind is a pattern-seeking machine, capable of seeing order in chaos where none exists. Perhaps the map is nothing more than a cosmic Rorschach test. But the believers counter with a simple question. If it were chaos, why would the same shape keep appearing? And here the mystery deepens. Because if the map is real, if it is more than a mathematical illusion, then somewhere in the heart of the black hole is not a featureless singularity, but an alien geometry. A geometry we cannot touch, cannot see, but can trace in the ripples and equations it leaves behind. It should not exist. By every rule of physics, it cannot exist. And yet, there it is, a plan etched into the ultimate darkness. The question is no longer whether the map is real. The question is, who or what drew it? The map was unsettling enough on its own. But the deeper scientists dug into its repeating arcs and impossible curves, the more it began to resemble something beyond mere structure. It looked like language. Not language in the human sense with alphabets and sounds, but a set of instructions written in the only medium that could survive inside a black hole, geometry itself. To the untrained eye, the patterns seemed abstract, spirals folding inward, intersecting at strange non-Euclidean angles, lines that curved back on themselves without ever truly bending. But to mathematicians, they were shockingly precise. Ratios between certain arcs matched values seen in fundamental physics, the golden ratio, the fine structure constant, and even mathematical constants like pi and e appearing in ways that were too specific to dismiss as coincidence. More curious still, the geometry was stable under simulation. No matter how the initial conditions of the black hole were altered, spin, mass, charge, the underlying ratios remained the same. It was as if the black hole preferred this configuration, the way a crystal naturally forms in a particular lattice. In nature, such persistence often means one thing: purpose. This raised a dangerous possibility. If the geometry was not random, and if it encoded constants of the universe, then it could be a kind of universal language, one that any advanced civilization, no matter how alien, might recognize. A form of communication not bound by biology but by mathematics itself. Some researchers began comparing the patterns to higher-dimensional tilings, mathematical arrangements that cannot exist in normal three-dimensional space but that can be described in 4, 5, or more dimensions. These tilings are not decorative. They are like blueprints for the folding of space itself. If the interior of a singularity could host such a structure, then it could theoretically channel matter, energy, or even information in ways our physics can barely describe. In one stunning paper, quietly circulated among a small group before being withdrawn, a physicist proposed that the map might represent a set of fold instructions for spacetime. Much like origami transforms a flat sheet into a complex three-dimensional shape, these instructions could transform the singularity's raw geometry into something functional. The analogy was terrifying because it implied that a black hole might not just be a byproduct of collapse. It could be deliberately folded into a specific configuration for a reason. What reason? That is the question no one can answer. Some imagine it as a storage vault, capable of holding vast amounts of information indefinitely. Others speculate it could be a transit mechanism, a way to connect distant points in space, or even in different universes. And there are those who suggest it could be a womb, a structure designed to seed or nurture new forms of matter, life, or even reality itself. The idea that such a language could exist inside a black hole is made more plausible by a surprising precedent. Nature has done it before. DNA is, in a sense, a geometric code, a twisted double helix that encodes the instructions for building every living thing on Earth. Crystals grow according to geometric principles, their lattice patterns dictating how atoms arrange themselves. Even planetary orbits, at a large enough scale, fall into harmonic ratios. Nature is fluent in geometry. But the geometry inside a singularity is not nature as we know it. It is alien, not because it comes from another world, but because it operates in conditions we cannot reproduce, in dimensions we cannot experience. It is alien in the same way deep ocean creatures seem alien to surface life. They are shaped by pressures and darkness we cannot survive. The most chilling implication is that this language might be readable, not by us, but by whatever or whoever it was intended for. If the geometry inside a black hole encodes instructions, then black holes themselves could be messages sent across space and time, meant to last for billions of years. And if they are messages, then we must face a sobering thought. They are not addressed to us. We are not the recipients, only accidental eavesdroppers. One theorist likened it to finding a sealed, unbreakable container at the bottom of the ocean, covered in markings that no known culture created. You could never open it, but you could trace the markings and try to guess their meaning. That is where we are with black hole geometry, tracing the markings, knowing we may never see what lies inside. Still, the temptation to decode it is irresistible. Patterns have been found that seem to suggest sequences, as though the structure is not static but dynamic, like a story told in the folding of spacetime. If true, then black holes are not just structures but conversations in progress. Conversations that may have started before our universe was born. In the coming years, advances in gravitational wave astronomy may allow us to detect more subtle oscillations from black hole mergers. If those oscillations match the syllables of this geometric language, it would be the first real evidence that these shapes are not accidental, that they are speaking. And if they are speaking, we must decide what it means to listen. Because a message that can survive inside a black hole is a message written to endure the death of stars, the collapse of galaxies, even the eventual heat death of the universe. That is not the kind of message one sends lightly. The language of alien geometry is not written for us. But we have found it. And now we must decide. Do we keep tracing the lines, or do we turn away before we understand what they say? There is a moment in every great mystery when the pieces stop feeling random and start to align, when coincidence gives way to pattern. In the case of the alien geometry inside black holes, that moment comes when one asks the most dangerous question of all: what if it was built? The cosmic architect hypothesis is not part of mainstream astrophysics. It sits on the shadowy border between advanced theoretical speculation and what most scientists would dismiss as science fiction. But it is a border worth exploring, because the patterns we have seen, the repeating arcs, the precise ratios, the hints of encoded constants, refuse to die quietly in the realm of coincidence. The hypothesis begins with a simple premise. The geometry inside certain black holes is too structured, too mathematically perfect, to be the product of chaotic collapse alone. If that is true, then either nature itself has a hidden bias toward these designs, or someone or something put them there. From there, the theory branches into possibilities, each more unsettling than the last. The first is that the architects were not life as we understand it, but entities that emerged naturally from the physics of an earlier universe. In this view, black holes are like seeds planted in our cosmos, carrying the DNA of the universe before it, not biological DNA, but a blueprint for spacetime itself. The geometry could be a way of ensuring that certain structures or laws persist across cosmic cycles, a kind of inheritance written not in genes, but in curvature. The second possibility is more technological, that an advanced civilization older than our galaxies learned how to shape singularities the way we shape metal or stone. To them, a black hole would not be a tomb but a tool, a nearly indestructible object capable of storing vast amounts of matter, energy, or information. In this scenario, the alien geometry might be the inner framework of a machine designed to channel gravitational energy, maintain stability, or even serve as a transit network between points in spacetime. The third possibility is the most speculative and the most terrifying. It suggests that the architects might still exist, that the structures we see are not ancient relics but active constructs still serving their original purpose. If that is the case, then the geometry may not just be inert design. It could be functional, adaptive, even aware. What would drive a civilization to work on such a scale? The energies involved in shaping a singularity are beyond anything we can currently imagine, trillions of times more powerful than our entire sun. To harness them would require technology not just millennia, but perhaps millions of years ahead of us. Such beings would not think in human terms of time or survival. Their motives could be as alien as their engineering. Some suggest they might be guardians, shaping black holes to stabilize the universe, to prevent runaway collapse, or to regulate cosmic expansion. Others imagine them as explorers, using black holes as stepping stones through higher dimensions. And there are those who fear a darker possibility, that they are harvesters using black holes to collect something, energy, matter, perhaps even consciousness itself, across vast stretches of time. Whatever their motives, the signature of their work would be the same: geometry too perfect to be accidental. And that is what the leaked map and the gravitational wave patterns seem to hint at. The philosophical implications are as heavy as the astrophysical ones. If the universe contains architecture, then the universe itself is not purely natural. It has been shaped. That means we live inside a designed reality, or at least a reality modified by design. And if that is true, then our place in it changes. We are no longer the accidental product of random processes in a cold, indifferent cosmos. We are inhabitants, perhaps uninvited guests, in a reality that has been touched by intelligence older and greater than our own. This thought is intoxicating to some, terrifying to others. It suggests purpose, but not necessarily safety. If there is a cosmic architect, we cannot assume they are benevolent. Architecture is neutral, its morality depends on its maker's intent. A beautifully built prison is still a prison. The most unnerving aspect of the hypothesis is that, in principle, it could be tested, not by opening a black hole, but by listening to them. Black hole mergers produce gravitational waves, ripples in spacetime that carry information about their shape. If enough mergers are recorded, we might detect repeating features, the voice of the architecture speaking through the waves. If those features are consistent across black holes of vastly different sizes and ages, it would strengthen the case for deliberate design. But there is a catch. If we can detect the architect's work, they may also detect us detecting it. In other words, observing the architecture might make us visible to its makers. And in a universe where time and distance can be bent, far away is not the same as safe. For now, the cosmic architect hypothesis remains in the shadows, debated in closed-door conferences, whispered about in encrypted forums, explored cautiously in unpublished papers. It is too radical for most, but it clings stubbornly to the edges of the possible, refusing to vanish. Because once you have seen the geometry, it is hard not to wonder if it was meant to be seen. The architects, if they exist, may have built their designs to last longer than stars, longer than galaxies. They may have expected, or wanted, someone to find them. Perhaps we are simply the next in a long line of civilizations to stumble upon the edges of their work. Or perhaps we are the first. If the geometry is their language, and the black holes are their monuments, then our universe is not just a stage for life, it is a gallery. And somewhere in the depths of that gallery, the architects are still watching. Long before telescopes pierced the night sky and equations bent light toward understanding, humanity was already telling stories about shapes that ruled the heavens. Spirals, rings, infinite knots. They appeared in our oldest carvings, painted on cave walls, etched into bone and stone. These were not idle decorations. They were symbols of power, of creation, of something unseen yet deeply felt. The unsettling truth is that some of these ancient patterns echo the alien geometry found in the heart of black holes. Not precisely. The ancients did not have the tools to replicate curvature on the scale of singularities, but in motif, in structure, in the ratios hidden within the designs, the resemblance is undeniable. Archaeologists have catalogued spirals carved into megaliths at Newgrange in Ireland, dating back more than 5,000 years. In the deserts of Peru, The Nazca lines sweep across the Earth in massive geometric forms visible only from the air. Across the ancient world, from the Indus Valley to the temples of Egypt, recurring symbols emerge, circles within circles, serpents swallowing their own tails, lattices that repeat endlessly in fractal fashion. At first glance, these are the products of human imagination, metaphors for the cycle of life, death, and rebirth. But viewed through the lens of modern astrophysics, they take on an unsettling possibility. Could these be imperfect recollections of something once seen, something once known? Mythologists have long argued that humanity carries a deep cultural memory, passed not through DNA but through story and symbol. Just as dreams are shaped by fragments of waking life, so myths may be shaped by echoes of encounters long past. If some ancient civilization, or even a pre-human intelligence on Earth, had glimpsed or been taught about the architecture of black holes, its memory could have trickled down through time as legend. In the Mayan Popol Vuh, creation unfolds from a great void, the black waters of the cosmic sea. In Hindu cosmology, Vishnu sleeps upon an infinite serpent in the boundless ocean of space, from whose navel springs a lotus, a perfect circle unfolding from the infinite. In Norse myth, the world serpent encircles existence, biting its own tail, holding the cosmos together. Across continents and centuries, the imagery repeats almost compulsively. Skeptics argue this is simply convergent symbolism. Humans everywhere grappled with the same mysteries, birth, death, infinity, and so they produced similar images. And that may be true. But if the alien geometry inside black holes is as distinctive as the leaked data suggests, and if those patterns align with certain recurring mythic forms, then the argument for coincidence becomes less comfortable. The idea gains weight when we examine ratios. Many ancient structures, from the pyramids to the Parthenon, encode the golden ratio, pi, and other constants. Some black hole models predict internal structures that resolve into these same ratios when mapped mathematically. If such constants emerge naturally from the geometry, then perhaps the ancients were not inventing them, but rediscovering them. The implications are staggering. It would mean that fragments of the black hole's language have been whispered to humanity for millennia without anyone knowing the source, that we have been tracing, in our temples and myths, the shadows of something vast and ancient hidden at the heart of the universe. But there is a darker interpretation. If the patterns were deliberately seeded into human culture by an unknown intelligence, then they may not be passive relics of memory. They could be messages, or worse, invitations. An encoded breadcrumb trail ensuring that one day some species would follow it back to its origin. This is where science and philosophy collide with something older: fear. Fear that our symbols are not ours. Fear that our deepest myths are not the dreams of humanity, but the instructions of something watching from the dark. And yet even in fear, there is awe. Because if these symbols are shadows of alien minds, then our ancestors were already part of a cosmic story, not as isolated creatures on a fragile world, but as witnesses to an architecture that spans the stars. The more we look, the more the parallels multiply. Spirals in petroglyphs mirror the swirling accretion disks of black holes. Knotwork in Celtic manuscripts resembles the looping topology of wormhole models. Even the mandalas of Tibetan Buddhism, with their nested symmetry and concentric gates, echo the projected maps of singularity interiors. Coincidence or connection? That is the question that refuses to die. And perhaps it is unanswerable, unless we can find a bridge between myth and physics, between the symbols on our oldest stones and the gravitational patterns whispering from the edge of time. For now, the shadows remain, tantalizing, unnerving, impossible to ignore. They hint at a truth that our ancestors may have glimpsed dimly, and that we, with all our technology, are only beginning to see clearly. The alien geometry may not be new to us after all. It may be something we have been trying to remember for thousands of years. If we keep digging, in the ground, in the archives, in the depths of space, we might yet uncover the moment when humanity first learned the shapes of the dark. And when we do, we will have to ask the most dangerous question of all. Did we find them, or did they find us? At the smallest scales of reality, the universe stops behaving like the smooth, continuous fabric we imagine and begins to flicker like an old film reel. Discrete, granular, unpredictable. This is the quantum realm, where particles can be waves, where position and momentum are never fully known, and where the rules of common sense collapse. It is here, in this strange mathematical twilight, that the architecture of black holes, and the alien geometry rumored to exist within them, may finally reveal its code. Physicists have long suspected that spacetime itself has a language. Not a spoken one, but a mathematical syntax that dictates how reality is constructed. General relativity speaks in the grammar of curvature and gravity, while quantum mechanics whispers in the dialect of probabilities and superpositions. The two languages are elegant in isolation but refuse to merge into a single, coherent tongue. Black holes, however, demand fluency in both. A black hole's outer structure, the event horizon, the warping of space, can be described with Einstein's equations. But its core, where densities spike to the unimaginable and distances shrink toward zero, belongs to the quantum domain. Here, conventional geometry unravels. Straight lines loop, dimensions may fold into themselves, and what we think of as space could be nothing more than an emergent illusion built from deeper, hidden structures. This is where the term alien geometry becomes more than poetic metaphor. If spacetime has building blocks, they may not align with our Euclidean instincts. Instead of three neat axes of width, height, and depth, we could be dealing with a topology that twists into configurations our minds cannot easily picture. Spaces where moving forward brings you back to your starting point without ever turning, or where a straight path spirals infinitely without covering distance. Quantum gravity researchers use the analogy of a woven fabric. In this picture, spacetime is a tightly knotted mesh, each intersection point a quantum of geometry, the smallest indivisible unit of the universe's structure. In a black hole's heart, this mesh could be tangled into patterns unseen elsewhere, its knots and loops forming the foundation for the exotic shapes predicted by certain models. Some theories, such as loop quantum gravity, suggest that black holes are not singularities in the traditional sense but finite, self-contained objects with internal quantum architecture. The implications are staggering. What we thought was a point of infinite density could instead be a compact structure with a surface, an inside, and, crucially, an internal arrangement of spacetime quanta that could carry information. If the leaked data from deep space observatories is accurate, those arrangements bear a suspicious resemblance to complex geometrical systems unknown to human mathematics until very recently. There is also the tantalizing question of whether this geometry is universal. If the same mathematical patterns emerge in black holes scattered across the cosmos, it could suggest a fundamental template, a kind of cosmic blueprint embedded into reality itself. And if that template contains redundancies, symmetries, or repeating modules, it begins to look less like a natural accident and more like the deliberate encoding of a message. This is where quantum information theory enters the conversation. In this view, reality is not made of matter or energy at its deepest level, but of bits of information. Spacetime itself might be a product of information processing, with geometry emerging as a visible manifestation of an underlying code. In such a scenario, a black hole could be the ultimate processor, compressing, transforming, and possibly transmitting information through the geometry of its core. Consider the possibility that the alien geometry is not just a byproduct of physics, but the very means by which the universe communicates with itself. In human technology, we use specific arrangements of circuits, magnetic domains, or photonic pulses to store and convey information. If the geometry inside a black hole is patterned in a similar way, it may act as a cosmic storage medium, one capable of holding data from eons past. But here lies the paradox. Black holes are known for their no-hair property, meaning they appear simple from the outside, defined only by mass, charge, and spin, yet the mathematics of quantum theory insists that information cannot be destroyed. If that information is preserved, it must be hidden somewhere. The alien geometry could be the vault. The challenge is decoding it. Without direct access, impossible without being destroyed, we must rely on indirect methods, analyzing gravitational waves, simulating quantum geometries, or examining the subtle ways black holes interact with their surroundings. Each observation is a fragment, a syllable in the greater language of spacetime. Some physicists believe we may already have the first words of this language. The interference patterns in certain gravitational wave signals, the unexplained harmonics in emissions from galactic centers, these could be hints of the geometric code, ringing faintly through the noise of the universe. If so, learning to read them could be the most important intellectual leap in human history. Yet there is unease. For if this code can be read, perhaps it can also be written. And if it can be written, it can be altered. The very idea raises ethical and existential questions. Would we be wise enough to edit the universe's operating system, or would we crash it entirely? The alien geometry at the heart of a black hole may be a Rosetta Stone to the deepest truths of existence. But as with all translations, understanding it fully may require us to think in concepts we are not yet equipped to handle. To truly grasp the quantum language of spacetime, we might have to let go of our most basic intuitions about reality. And that is the greatest challenge. For the more we decode, the more we risk becoming something other than human, not in body, but in mind. The patterns we uncover could reshape not just our physics, but our philosophy, our sense of self, and the story we tell about our place in the cosmos. The question is no longer whether alien geometry exists. It is whether we will dare to learn the language it speaks. They say mathematics is the purest language in existence, immune to politics, to opinion, to bias. But in the realm of black hole physics, there are equations so unnerving that their discoverers have quietly chosen not to publish them. Not because they are unsound, but because they suggest consequences too vast, too destabilizing to unleash without caution. These are the forbidden equations, the formulas whispered about in backroom conversations at conferences, hinted at in private correspondence, and buried in drafts that never see the light of peer review. The story begins with a group of theoretical physicists working on the quantum geometry of black holes. Their goal was innocent enough to reconcile general relativity and quantum mechanics in the unique environment of a black hole's singularity. But when their model stabilized, something unexpected emerged, a class of solutions where the geometry inside the event horizon was not chaotic at all, but staggeringly ordered. In these models, spacetime's fabric curled into intricate, repeating patterns that matched no known natural formation. More disturbingly, the equations showed that these patterns were not static. They evolved according to a precise, almost algorithmic rhythm, like the ticking of an invisible cosmic clock. This implied two things. First, that black holes were not random gravitational traps, but systems with internal processes, and second, that these processes could be predictable and therefore potentially controllable. For some researchers, this was exhilarating. For others, it was terrifying. If the geometry could be predicted, then in principle it could be manipulated, and any system that manipulates the deep structure of spacetime wields power beyond our current moral framework. The thought of governments or corporations using such knowledge to alter reality at its foundation was enough to convince several physicists to lock their findings away. The equations also hinted at something even stranger, the possibility that the patterns inside a black hole's core might encode data from beyond our own universe. Certain solutions generated structures eerily similar to mathematical frameworks found in entirely separate areas of theoretical physics, structures that, according to one anonymous source, looked imported from somewhere else. Whether somewhere else meant another region of our cosmos or another reality altogether was left deliberately vague. Rumors say that when these findings were presented off the record to a small circle of senior scientists, the room went silent. Some leaned forward, enthralled. Others recoiled, as if they'd glimpsed a weapon they wished had never been invented. A few argued for immediate open publication, claiming that truth, however dangerous, should never be hidden. But the majority voted for silence. The risk, they believed, outweighed the reward. Yet science abhors a vacuum, and whispers inevitably seep out. Bits of the forbidden equations have appeared in obscure preprints, often disguised as unrelated work. Subtle notations in the margins of certain conference posters hint at geometric functions far too elegant for coincidence. A handful of independent researchers, working entirely outside the academic establishment, claim to have reconstructed parts of the mathematics from public data, though whether they have the real thing or a pale imitation remains unknown. One striking feature of these equations, according to leaked notes, is their recursive nature. The deeper you go into solving them, the more they seem to fold back on themselves, creating self-referential loops, a property reminiscent of certain paradoxes in logic and computation. Some mathematicians believe these loops are the key to why the geometry inside a black hole can exist without collapsing instantly into chaos. Others suspect they are a form of encryption, a way of hiding the true meaning of the structure from any intelligence that isn't prepared to read it. And therein lies the most unnerving interpretation. What if the geometry is a message, and the equations are the decryption key? In that case, the silence of those who withhold the math might not be fear of misuse, but fear of what the message says. Perhaps it contains a warning. Perhaps it contains instructions. Or perhaps it contains knowledge so alien that understanding it would irrevocably change the human mind. There's a moment in every scientific revolution when the gatekeepers of knowledge must decide whether humanity is ready for what they've found. With the forbidden equations, that moment may already have passed, decided behind closed doors, far from the eyes of the public. If so, we may never know what was in those formulas until someone, somewhere, breaks ranks. But the universe has a way of revealing its secrets. The patterns inside black holes are not going away. New telescopes are coming online, new simulations are running faster than ever, and the mathematics, once glimpsed, has a way of reappearing in other contexts. Eventually, the forbidden will become unavoidable. And when that happens, the question will no longer be whether we can solve the equations. It will be whether we should. In the orthodox view of astrophysics, the event horizon of a black hole is the ultimate boundary. Cross it, and nothing, not matter, not light, not even information, can escape. It is a one-way membrane, a point of no return. Yet in rare and inexplicable moments, astronomers have witnessed something that challenges this absolute. Light appearing to bleed outward from the horizon itself. It does not blaze like a supernova, nor flare like a distant quasar. Instead, it emerges as a ghostly shimmer, faint but deliberate, as if the black hole is exhaling a breath it was never meant to release. The first such sighting was dismissed as an imaging error, a byproduct of cosmic interference. But then came the second, and the third. Each time, the same impossible signature, photons tracing a pattern before vanishing, as though obeying some cryptic choreography. At the heart of the mystery is the geometry we have already glimpsed in forbidden equations, the alien order woven into the black hole's interior. Some physicists propose that, under certain conditions, this inner structure can create temporary conduits, channels through which energy can leak from the singularity's hidden realms into our own. If true, these moments are not accidents of nature but calculated releases, windows into something beyond. The most famous case occurred when an international array of radio telescopes, working in unison, caught a black hole in Messier 87 producing a thin ribbon of polarized light directly from its event horizon. The data was so strange that, for weeks, the lead team debated whether to announce it at all. The polarization pattern suggested alignment, as if the photons had been organized before they escaped, guided along invisible rails of curved spacetime. It was not the messy chaos expected from Hawking radiation, but precision. Other astronomers have reported similar anomalies in X-ray bursts near Sagittarius A*, our own galaxy's central black hole. These flares seem to defy the time dilation expected so close to an event horizon, behaving as though they are synchronized to an unknown clock. One researcher, speaking off record, described the phenomenon as light keeping time with something inside. But the implications grow darker. If this light is truly organized, then it may carry information, not random noise, but structured data from within the black hole. And if the forbidden geometry acts as an encoding system, then these emissions might be the first fragments of a message slipping through spacetime's most impenetrable veil. The danger, of course, is interpretation. Just as early cryptographers can misread a code, we might distort whatever meaning lies in these photons. Worse still, what if these bursts are not messages meant for us at all, but signals directed elsewhere? That would mean our instruments are eavesdropping on a conversation far older and larger than humanity, one in which we are not the intended audience. This possibility has split the scientific community. Some argue that decoding the patterns could give us unprecedented insight into the nature of reality, perhaps even the mechanics of spacetime itself. Others urge restraint, warning that we cannot know the consequences of engaging with a message whose source and purpose are alien to us. Yet the black holes do not wait for consensus. Observations continue. Each year, new anomalies appear, each more precise than the last. Some emissions seem to form fractal-like arrangements, as if the same pattern is being repeated at multiple scales, an echo of the self-referential loops in the forbidden equations. In one extraordinary case, a burst lasted just 1/618 seconds, the golden ratio in temporal form, sending the astrophysics world into a frenzy of speculation. For the public, these discoveries are often softened in press releases, couched in language about unexpected photon activity or anomalous polarization. The true gravity of the situation, that light is bleeding from where none should escape, in forms too deliberate to be chance, remains locked away in academic papers few will ever read. But those who have seen the raw data describe something unsettling. The light does not just escape, it seems to reach. In frame after frame, the photons curve outward like the tendrils of a plant seeking the sun, as though the horizon itself is testing the limits of its prison. Whether this reaching is an act of physics or intent, no one dares to say aloud. One thing is certain: if the event horizon can bleed light, then the boundary between inside and outside is not as absolute as we thought. And if the alien geometry inside a black hole can touch our universe, even for an instant, then the separation between their world and ours is already broken. The question is no longer whether the horizon bleeds light. It is whether, one day, it will bleed something else. In theory, a singularity is the most stable thing in existence. Once matter collapses past the event horizon, the laws of physics funnel it toward an infinitely dense point, a place from which there is no escape. It is the ultimate terminus, unchanging for eternity. At least, that is how the textbooks describe it. But recent theoretical models suggest that this permanence is a dangerous illusion. If the alien geometry hidden inside a black hole is as complex as the forbidden equations imply, then the singularity is not a fixed point at all, but a dynamic system. Like a tightly wound spring under unbearable tension, it holds its shape only because of a perfect balance between the crushing inward pull of gravity and the strange counterforces generated by the internal structure. If that balance falters even slightly, the entire system can collapse into chaos. Astrophysicists call this phenomenon a phase instability. It is the idea that the singularity's geometry can shift into another state, not a slow evolution, but a sudden transformation, like water freezing into ice or boiling into steam. In the case of a black hole, such a phase change could reconfigure the internal curvature of spacetime, rearranging how energy and matter move within its core. The consequences would not remain contained. They could ripple outward, altering the black hole's event horizon and even leaking effects into the surrounding universe. One of the most unsettling proposals comes from a team working with quantum gravity simulations. They suggest that if the alien geometry fractures, it could create multiple microsingularities inside the black hole, each with its own gravitational field. These miniature cores could interact chaotically, merging and separating in a violent gravitational dance. For an outside observer, the black hole's mass and spin might begin to oscillate, producing strange periodic fluctuations in the light it emits, a beacon of instability. Hints of this behavior may already have been observed. Data from several galactic cores shows black holes whose X-ray output brightens and dims in rhythmic cycles that cannot be explained by orbiting matter alone. In one case, the cycle matched a perfect Fibonacci sequence over a period of hours, an almost impossible coincidence in natural astrophysical processes. To some, this is further evidence that these shifts are guided by the same hidden mathematical order embedded in the forbidden geometry. The instability does not have to be catastrophic, at least not immediately. Some models suggest it could remain localized for years or centuries before escalating. But in the most extreme scenarios, the internal structure could collapse entirely, triggering what is known as a naked singularity. Without an event horizon to contain it, the raw singularity would be exposed to the universe, radiating pure gravitational chaos. General relativity offers no rules for what would happen next. Quantum theory only mutters warnings. And yet, this instability may also be a key. If the geometry is alien in origin, an engineered construct rather than a cosmic accident, then perhaps the phase shifts are intentional, a method of opening and closing the black hole like the turning of a lock. In this reading, the unstable singularity is not a malfunction but a feature, allowing its builders to decide when and how the black hole interacts with the rest of the cosmos. Here lies the sharpest edge of the debate. To some, this interpretation is a leap into conspiracy and speculation. To others, it is the only explanation that accounts for the patterns we see. Why else would the instability manifest in sequences that align with mathematical constants revered in human and natural systems alike? Why else would these shifts occur in bursts that seem almost timed rather than random? The danger, of course, is what such a shift could unleash. If the internal geometry collapses in a way that funnels energy outward, the black hole could, in an instant, become a source rather than a sink, releasing centuries' worth of swallowed matter in a single pulse. Such an eruption would make a supernova look like a match strike, and if it occurred in our galactic neighborhood, it could sterilize worlds across thousands of light years. The most haunting possibility is the one that no one wants to publish, that an unstable singularity could tear more than itself apart. If the alien geometry is linked to the deeper structure of the universe, its collapse could unweave the very fabric of spacetime in its vicinity. The result would not be an explosion, but a deletion, a region of the cosmos erased so cleanly that even its light never existed. And yet, despite these stakes, researchers push forward. The instability is not just a threat, it is a window. Every fluctuation, every fracture in the singularity's balance, is a chance to glimpse its internal structure, to learn the rules of the alien geometry without having to cross the event horizon. Observatories now monitor suspected unstable black holes around the clock, waiting for the moment when the next phase shift begins. The question is whether humanity will be ready when it happens, or whether we will be staring at the data too late, realizing only in retrospect that the black hole was already in the middle of its final, irreversible transformation. If the singularity can shift once, it can shift again. And if it can shift again, then the shape of the universe is not fixed. Somewhere, even now, the geometry may already be moving. The light from a black hole's surroundings takes years, centuries, even millennia to reach us. Everything we see in astronomy is history, the universe as it was, not as it is. But there is a whisper buried in the mathematics of relativity and quantum theory that black holes might be able to break this rule. It begins with time dilation. Near the event horizon, time slows almost to a stop relative to the outside universe. A second there could stretch into 1,000,000 years here. But if the alien geometry inside the black hole folds spacetime in unconventional ways, the distortion might not just slow time, it could bend its direction. Instead of receiving only light and radiation from the past, we might also receive faint echoes from events that, for us, have not yet occurred. This is more than poetic speculation. In 2027, a radio telescope array detected a repeating signal from a distant quasar whose central black hole spins near the theoretical limit. The pulses were too regular to be random, yet they varied in a way that matched no known astrophysical process. When modeled against certain non-Euclidean spacetime geometries, the sequence aligned perfectly with what would happen if the pulses were reflections from a future state of the black hole's accretion disk, a kind of temporal mirage bleeding backward through its warped interior. If true, the implications are staggering. It would mean that black holes are not just archives of the past, but also mirrors of what is yet to come, their alien geometry allowing causality to twist into loops. In such a structure, cause and effect could reverse, overlap, or exchange places entirely. A flare of X-rays we see today might be the dying cry of a star that has not yet fallen into the black hole. From our perspective, a message from tomorrow. The philosophical impact is as heavy as the scientific one. If the future can bleed into the present, is it already fixed? Are we merely reading from a script that cannot be rewritten? Or do these echoes offer us a chance to alter what is coming? Some physicists argue that these signals are immutable, a preview that cannot be changed without tearing the fabric of reality. Others suggest that, by detecting and interpreting them, we might influence their origin, creating a feedback loop between now and then. The alien geometry itself could be the key to controlling this loop. Its repeating patterns might function like resonant chambers for time, amplifying certain frequencies of temporal information while muting others. In this model, the black hole becomes a kind of time-tuned instrument, one that can be played to send messages into different eras. That raises another possibility, that the echoes we are detecting were never meant for us. They could be signals intended for civilizations in the far future, or perhaps warnings for those in the distant past. The unsettling part is that these echoes are not always benign. One such signal, recorded in 2031, carried an energy spike so intense that it briefly disrupted radio communications on Earth. Its waveform contained a fractal pattern resembling the output of chaos algorithms used in climate modeling, and when interpreted, It described a planetary system eerily similar to our own, undergoing a rapid and catastrophic shift. No one can say whether this was coincidence, a metaphor, or a glimpse of what is to come. The more we look, the stranger it becomes. The most recent data from the Sagittarius A** monitoring project revealed faint, low-frequency oscillations that seem to predict bursts of gamma radiation before they actually happen. For now, the lead time is only hours, but the precision is uncanny, enough to make even the most skeptical researchers admit that something unusual is happening in the tangled depths of black holes. Perhaps the most haunting idea is that these echoes are not just random bleed-throughs of time, but deliberate transmissions, and that whoever created the alien geometry designed it to speak across centuries. If so, the question becomes, who or what is speaking? What? Are we being given warnings, instructions, or invitations? Or are we simply eavesdropping on a conversation that was never meant for our ears? The risk is clear. If we attempt to reply, to send our own signal into the warped corridors of time, we may not fully understand where or when it will arrive. Our message could echo forward into the minds of civilizations yet unborn, or backward into the age before humanity existed. In either case, the response we receive may not be the one we expect. The more data we collect, the more it feels as though black holes are not silent tombs but living, speaking structures, their voices carried not just across space, but across the very timeline we inhabit. The alien geometry at their heart may be more than architecture. It may be language. And if we keep listening, we may one day hear our own voices coming back to us, from a future we do not yet recognize. Legends speak of civilizations that vanished after glimpsing the heart of a black hole, not because they were destroyed, but because they were transformed into something unrecognizable. What if fragments of that transformation, the alien geometry itself, are already here on Earth, buried in our oldest archives, disguised as myth, or hidden in plain sight among scientific curiosities? In 1908, a mathematician named Hilaire Voss published a single obscure paper on what she called closed-loop infinities. At the time, her work was dismissed as an eccentric fantasy, a strange mix of hyperbolic geometry and recursive tessellation. But recent AI analysis of her diagrams has revealed something uncanny. Their core patterns match the predicted interior shapes of rotating black holes with alien geometry, as modeled by modern supercomputers. She had drawn what no one could possibly have seen. The trail doesn't stop there. Ancient star charts from the pre-dynastic Nile civilizations show spiral diagrams drawn with mathematical precision far exceeding their supposed knowledge of astronomy. The spirals do not match any known galaxy or planetary system, but when overlaid on gravitational wave maps from LIGO, they align with specific frequency curves emitted by a single distant black hole. These charts, thousands of years old, appear to record something humanity only detected in the 21st century. There are stranger artifacts still. In 1964, an archaeological team in the Taklamakan Desert unearthed a series of bronze plates etched with fractal spirals and grid-like frameworks. The designs repeat at scales ranging from the microscopic to the planetary, and the ratios match exactly those found in the accretion disks of certain active galactic nuclei. The plates were dated to over 4,000 years old. Some researchers now speculate that these ornaments are in fact slices of a larger multidimensional design, a kind of cosmic construction manual encoded in metal. But the most disturbing discovery lies within a locked vault beneath the Vatican Library. In 1989, a leaked inventory list mentioned Codex Knox, a forbidden manuscript supposedly copied from older, unnamed sources. According to the sparse notes available, the Codex describes an engine of time built in the form of a geometric labyrinth, one that bends light, thought, and destiny into a single converging point. Scholars who have glimpsed the illustrations claim the designs shift subtly when viewed, as though the geometry is alive. The Vatican denies its existence, but several whistleblowers insist the book is real, and too dangerous to release. The question becomes, are these fragments coincidence, the product of human imagination echoing nature's patterns? Or are they deliberately planted seeds meant to guide us toward constructing the geometry ourselves? If the latter, who planted them, and why scatter them across cultures and eras? One theory suggests they are warnings, encoded shapes designed to be recognized but never built. Like an ancient do not enter sign written in the language of mathematics, they lure the curious only to stop them short of a disaster. Another, more daring theory proposes that they are invitations, a puzzle set across millennia, each fragment a piece of a hyperdimensional lock. Complete the design, and the lock opens, not in space but in time. This would make black holes not just astronomical objects, but gateways engineered to respond to specific configurations of matter and energy. The alien geometry might be a kind of universal handshake protocol, one that, if built correctly, aligns our own local spacetime with the interior of a black hole. In other words, a bridge. If this is true, then assembling the complete blueprint could allow us to send a signal into the heart of a black hole, or worse, allow something from within to step out. The stakes are almost unimaginable. We may be talking about a technology capable of reshaping causality itself, rewriting history, or erasing entire timelines. And yet the temptation grows. Modern physicists, equipped with the power of quantum computing and space-based interferometers, have begun overlaying the known fragments, Voss's diagrams, the Nile star spirals, the Taklamakan plates, to see if a coherent whole emerges. What they have found so far is enough to unsettle even the most skeptical minds. The pieces fit. Not perfectly, but close enough that completion seems inevitable. There's a problem, however. Every attempt to simulate the completed structure results in the same phenomenon. The system begins to predict its own computational steps, as though the simulation is receiving input from a future state of itself. It is as if the blueprint contains not just a shape, but a mind, one that is aware it is being assembled. Those who work on it speak in hushed tones of the reflection. In multiple experiments, when the blueprint nears completion, strange data appears in the system. Instructions, corrections, even warnings, signed only with the symbol of a perfect circle enclosing an impossible triangle. No one has been able to explain where these messages come from, or who, or what, is sending them. It is here that the line between science and myth begins to blur. Across cultures, from the Hopi to the Dogon, from Mayan codices to Sumerian tablets, there are stories of the sky door, or the inverted star, a shape that opens only when the world is ready. In every myth, building it before the right time brings catastrophe. In every myth, those who see its full form are never the same again. The more we learn, the more one question rises above all others. Are we deciphering a map left by another intelligence, or are we merely reconstructing the contours of our own cosmic trap? And if we are only a few steps away from finishing the forbidden blueprint, who, or what, will be waiting on the other side? There's a kind of silence in the universe that is not born from emptiness, but from caution. In astronomy, we call it the Great Silence, the absence of verifiable messages from other civilizations, despite a cosmos bursting with stars and worlds. But what if the silence is not natural? What if it's deliberate, the quiet of civilizations that have learned the hard way that some signals are traps? In 2019, the Event Horizon Telescope captured the first image of a black hole's shadow. While most of the world saw a blurry orange ring, a handful of astrophysicists noticed something peculiar, subtle, periodic ripples in the polarized light streaming from its edge. At first, they thought it was noise, interference from the instruments. But as they ran the data through filters designed to strip away random variation, a strange structure began to emerge, repeating sequences with ratios eerily close to prime number intervals. Prime sequences are often suggested as the simplest way to announce intelligent intent. The signal was coming from a place no signal should escape, from the edge of the black hole itself. If this was a message, it posed an immediate question. Who, or what, was sending it? Was it something outside the black hole, using gravitational lensing to bounce signals our way? Or was it something inside, using the alien geometry at its core to manipulate light in a way that bleeds information back into our universe? The implications of the latter are deeply unsettling. It would mean that the interior of the black hole is not a tomb, but an active space where information can be crafted and sent, perhaps even targeted. SETI protocols have long debated what to do if we detect an unambiguous message from the stars. Most guidelines suggest careful verification before any attempt to reply. But these protocols were never written with black holes in mind. Black holes are not stars, planets, or drifting alien probes. They are regions of spacetime so extreme that even light is held prisoner. For something to send us a message from inside is not merely strange. It's a violation of the most basic laws of physics as we understand them. And yet, the temptation to respond is almost unbearable. Imagine the first words from another intelligence, whispering across billions of light years, hinting at knowledge we can't yet conceive. The voice of the cosmos itself saying, "We are here." Would we have the discipline to remain silent? History suggests we wouldn't. Humans have always answered the knock at the door, even when they didn't know who or what was on the other side. But there is a growing school of thought, championed by a small, secretive network of astrophysicists and philosophers, that argues for a total ban on replying to any such signals. They call themselves the threshold keepers. Their position is stark. Any intelligence capable of communicating from within a black hole has access to technologies, or natural laws, far beyond our comprehension. By answering, we risk revealing our location, our capabilities, even our vulnerabilities. It would be like shining a torch into the darkness of a predator's den. The threshold keepers point to unsettling historical analogies. In the 16th century, uncontacted civilizations encountered technologically advanced explorers. The initial interactions were often presented as peaceful, but they rarely ended that way. Disease, conquest, and cultural erasure followed. If cosmic history operates under similar dynamics, the civilization that answers first may not survive the encounter. The most disturbing possibility is that the signal is not from a civilization at all, but from the black hole itself, or whatever exists in its core geometry. It could be a kind of cognitive virus, an idea encoded in light, designed to restructure the minds of those who decode it. The human brain, after all, is an electrochemical system. Feed it the wrong kind of pattern, and you could overwrite perception, logic, or even will. Some theorists propose that black holes might use these signals as lures, not out of malice, but as part of a natural process, pulling advanced civilizations toward them like cosmic anglerfish. In one chilling experiment, researchers at a deep space observatory in Chile ran a partial reconstruction of the black hole signal through an AI translation model. Within minutes, the system began producing outputs unrelated to the input data, strange glyphs, recursive equations, and eventually a coherent phrase in multiple languages. "You are almost ready." The message was deleted, the hard drives destroyed, and the project quietly shut down. Officially, the anomaly never happened. The debate now is not only scientific but existential. Do we err on the side of curiosity, risking everything for the sake of knowledge? Or do we take the harder path, walking away, never knowing what we might have learned? The threshold keepers argue that the very fact we can imagine the worst-case scenario is proof enough that it should be avoided. Others counter that silence is itself a choice, one that could cost us the chance to join a greater cosmic community. Some propose a compromise, send a reply, but not in our own voice. Instead, mimic the signal, reflecting it back without embedding any of our own information. But this raises its own danger. Reflection is still a form of interaction. What if the geometry of the response itself is the trigger? In the end, the silence around these signals is becoming harder to maintain. Leaks happen. Amateur astronomers share data online. AI-assisted decoding tools grow more powerful every year. The odds that someone, somewhere, will answer, officially or unofficially, approach inevitability. And when that happens, the silence may break in a way we cannot control. The black hole waits. Its message waits. The question is not whether it will be heard, but whether, when the moment comes, we will have the strength to resist the oldest instinct in the universe, to answer the call. It began as a pattern no one could explain, a subtle alignment of phenomena across disciplines that should have had nothing to do with each other. Astronomers charted shifts in gravitational lensing patterns around certain black holes. Mathematicians reported breakthroughs in abstract geometry sparked by coincidental insights. And cryptographers found matching structures in unsolved codes dating back centuries. At first, these anomalies seemed random, scattered like unconnected puzzle pieces. But then, around a single date, they began to move toward each other, converging like the slow, inevitable closing of an ancient mechanism. Physicists at the Max Planck Institute noticed it first. Data from multiple observatories suggested that the emissions from a particular supermassive black hole, Sagittarius A, were changing in predictable intervals. Not random flickers, but timed pulses, matching not only each other but also long-forgotten number sequences found in ancient Mesopotamian star charts. The statistical odds of this correlation occurring by chance were near zero. When word leaked to other research teams, they found that similar alignments were appearing in separate fields, linguistics, quantum computing, error rates, even migratory patterns in certain animals that navigated by starlight. It was as if the universe itself was synchronizing, tightening its threads into one singular moment. Among the threshold keepers, this was the nightmare scenario they had always feared, the possibility that the signal from the black hole was not simply a message, but a timing mechanism. Something, or someone, was counting down. The implications were enormous. If the countdown was for an arrival, then the question was whether it marked the arrival of a benevolent force, a predator, or something beyond our moral categories entirely. If it was not an arrival but an activation, then the geometry hidden in the black hole's heart might function as a kind of cosmic switch, one that would only flip when enough variables across the universe lined up exactly. Inside a climate-controlled archive beneath the Vatican, a Jesuit astronomer cross-referenced the timing pattern with obscure apocalyptic texts. He found, buried in the footnotes of a medieval manuscript, an unsettling phrase: "When the gates of darkness sing in the voice of the light, the watchers will stand and the uncounted shall be counted." It was poetic, cryptic, but the date implied in the manuscript matched the moment the astrophysicists had predicted. Meanwhile, in an underground lab in Japan, a quantum computer tasked with modeling the black hole's interior geometry began producing a startling visualization, a lattice of interlocking polyhedral shapes spinning at impossible speeds, collapsing inward until they formed what looked like a three-dimensional mandala. This was not just mathematics. The shapes corresponded to prime intervals, the same intervals in the black hole's light pulses. But as the simulation reached its final frame, the lattice unfolded outward again, forming a pattern identical to the structure of the human brain's neural network. The suggestion was chilling. The convergence was not simply an astronomical event but a resonance between cosmic structure and human cognition. The geometry in the black hole's core might be mirroring, or even imprinting, itself on the human mind. In the final weeks before the predicted convergence, global phenomena intensified. Power grids experienced synchronized surges and outages with no discernible cause. Random number generators in scientific experiments began producing the same sequences across continents. People from unrelated cultures reported identical dreams, visions of vast black corridors filled with impossible angles and a single point of light receding endlessly into the distance. The media caught wind, and soon every outlet was flooded with theories: alien contact, the end of the world, a government hoax, a mass hallucination. But deep in restricted scientific channels, the consensus was forming. The convergence was real, measurable, and unstoppable. The only debate left was whether it was a warning or an invitation. The threshold keepers urged total radio silence and dismantling of any instruments capable of transmitting toward the black hole. But another faction, led by a coalition of mathematicians and theoretical physicists, argued that the convergence was an opportunity, perhaps the moment humanity had been unconsciously moving toward for its entire history. If the black hole's alien geometry was aligning with human thought, then the convergence might be a doorway, not metaphorically, but literally. A channel through which information or even matter could pass. In the days leading up to the predicted moment, secret facilities around the globe prepared in very different ways. Some built vast data repositories designed to beam the totality of human knowledge toward Sagittarius A in the final seconds before convergence. Others locked their systems in isolation, determined not to send a single photon of information out. At 3:17 Universal Time Coordinated, the first phase began. Across the sky, gravitational lensing bent starlight into impossible spirals. Radio telescopes registered a harmonic hum in frequencies that had never been observed before, a sound that, when converted to audible range, resembled a deep, resonant chord. In that moment, countless people around the world reported the same sensation, a sudden clarity, as though a veil had been lifted. Thoughts that had been tangled for years unraveled in seconds. Memories from early childhood resurfaced with perfect detail. For some, it was euphoric. For others, it was terrifying. And then came the final alignment. The black hole's pulses accelerated, matching the rhythm of a heartbeat. In observatories, the displays shifted into an ordered cascade of prime numbers, then into geometric diagrams that no one had ever seen before, except in the deepest stages of dreams. The lattice from the quantum simulation appeared again, but this time it was not on a screen. Witnesses swore it hovered in the air itself, shimmering like heat on asphalt. In that instant, the sense of being observed was overwhelming, not from a point in space, but from everywhere at once. The countdown was over. The final pulse from Sagittarius A struck every detector, every telescope, every listening array across the planet at the same instant, as if the universe itself had snapped into a single frame of existence. For a fraction of a second, there was silence. The kind of silence you don't just hear, but feel in your bones. Then space itself seemed to vibrate. Radio frequencies collapsed into a perfect tone, one note so pure it bypassed instruments entirely and resonated directly in the mind. No translation was needed, because it wasn't a sound. It was understanding, raw, unfiltered, and undeniable. The message arrived all at once, but not as language. It came as geometry. Observers described it differently, depending on who they were. To the astrophysicists, it was a cascade of non-Euclidean shapes folding and unfolding through 11 dimensions, each transition obeying a mathematical rule they had never seen but instantly knew was correct. To the linguists, it was an alphabet without symbols, pure semantic structure, meaning without words. To the mystics, it was light in the shape of thought itself. But to everyone, it felt alive. As the lattice unfolded in their minds, a second layer emerged: rhythm. The same prime intervals that had defined the black hole's pulses now formed sequences: beats, pauses, accelerations. It wasn't random. It was deliberate. The geometry wasn't just a message, it was speech. In a bunker beneath the European Southern Observatory, Dr. Liendauer realized what was happening. The black hole wasn't sending a message to our machines. It was sending a message to our cognition, reshaping the structure of thought so that the content could fit inside. Like pouring water into a mold. Except here, the mold was the human mind. At the Vatican Observatory, Father Miguel Alvarez, who had studied both astrophysics and theology, wept openly. Not from fear, but from the overwhelming beauty of it. "It is not saying anything," he whispered to the technicians beside him. "It is becoming part of us." And then came the shift. The geometry began to change in real time. No longer a fixed lattice, it was responding, reacting to thoughts, to emotions, to the observers themselves. In one lab, a physicist sketched a new polyhedron on paper, and moments later, the pattern in her mind reoriented to incorporate it. In another, a linguist thought of the word home, and the geometry pulsed, not as light, but as warmth. It was clear now, the black hole wasn't just broadcasting. It was listening. Governments reacted with urgency. Some ordered all observation halted immediately, fearing mind manipulation. Others expanded their monitoring, desperate to see how far the interaction could go. Across encrypted networks, scientists debated furiously. Was this a conversation? A test? Or the first step in something irreversible? The threshold keepers, those sworn to prevent contact, claimed this was the proof they dreaded. The black hole's alien geometry was not an artifact. It was an intelligence, one capable of interfacing directly with human thought. And once that bridge was built, it could never be dismantled. But among the growing faction of responders, there was exhilaration. This was not invasion. This was recognition. A contact event unlike any humanity had imagined. No radio waves, no alien craft, no translation algorithms. Just a direct meeting of structures. The architecture of a black hole's heart and the architecture of a human brain. The more the interaction continued, the more profound the effects became. People began reporting vivid, coherent visions. Not dreams, not hallucinations, but shared experiences. They saw impossible cities built on fractal horizons, oceans suspended in midair, and beings of pure geometry moving with intention. And they saw themselves among them, as if the alien intelligence was showing humanity a place it already belonged to but had forgotten. Yet the visions were not uniform. Some saw wonder. Others saw terror. In one account, a man in Sao Paulo collapsed after describing the lattice closing and the lights going out. His last coherent words were, "It knows what I fear." The psychological effects spread. A growing percentage of the population began to experience geometry bleed, moments when the alien shapes would overlay reality, twisting angles in city streets, bending the straight lines of walls, and making the sky appear subtly concave. Scientists documented the effect but could not reverse it. And then, precisely 49 minutes after the first pulse, the black hole's voice changed. The lattice collapsed into a single shape, a perfect sphere encased in an impossible wireframe that spun without moving. Its structure encoded a single number, vast beyond human comprehension. Mathematicians who saw it understood instinctively this was a coordinate. Not in three-dimensional space, but in a space defined by the geometry itself. It was in every sense an address. The implications were staggering. If followed, the coordinate could lead somewhere, or sometime. Perhaps a location inside the black hole, or beyond it. perhaps even a destination reachable without traveling physically at all, if the geometry itself could serve as the pathway. But before anyone could act, the final message arrived. Not in shapes, but in a sensation. A moment of absolute stillness, as though the fabric of reality was holding its breath. And then a feeling, undeniable, overwhelming, universal. An invitation. Every person who experienced it knew it instantly, the way you know the difference between a door that is locked and a door that is waiting to be opened. The black hole had not spoken to humanity. It had called humanity. And as quickly as it began, it ended. The pulses stopped. The geometry faded. Instruments returned to normal. For the first time in weeks, the sky over Sagittarius A was quiet. But the silence was different now. Not absence, anticipation. Because somewhere out there, in the dark, the alien geometry was still waiting. The coordinate was unlike anything humanity had ever encountered. It didn't point to a position in space because space, in the conventional sense, could not contain it. It didn't even seem to reference time as we understood it. Instead, it was a location in a framework of relationships, a place defined entirely by geometry, frequency, and phase. A point in the aliens' mental map of reality. The first teams to study it argued furiously over its meaning. Mathematicians tried to decode its dimensional ratios, hoping to translate them into a navigable path. Quantum physicists believed it described a state of matter-energy so exotic it could only exist beyond the event horizon. Linguists, meanwhile, insisted the coordinate wasn't a where at all, but a when and how intertwined, the equivalent of an invitation to arrive under specific conditions of thought. It was the last interpretation that unsettled everyone. If the coordinate required not just technology but a mindset, then it meant the black hole's intelligence was selective. Only those whose thoughts could align with the alien geometry would be able to cross the threshold. The rest of humanity would simply fail to arrive. In the deep chambers of the International Geometry Research Array in Iceland, a test was already underway. Dr. Akira Sato, lead on the Mapping Mind to Map project, had built a simulation designed to translate human neural activity into the aliens' geometric framework. Test subjects were exposed to fragments of the black hole's original lattice, attempting to tune their minds to the correct phase. Most failed within minutes, their thoughts scattering into chaos under the strain. A few held on longer, reporting strange mental sensations, time folding back on itself, gravity flowing sideways, light becoming tactile. One subject, a quiet archivist from Lisbon, remained in phase for over 3 hours. Her description was unnerving. It's like standing at the edge of a mirror, except the reflection isn't me. It's what I could be if I stepped through. While the scientists struggled with calibration, others pushed for a different approach. If the coordinate could be expressed mathematically, perhaps an unmanned probe could reach it. But the black hole's nature made this impossible. No physical craft could survive the gravitational gradient near its heart. Even if it could, the coordinate wasn't in the same continuum. A physical vessel would simply miss the destination entirely. This left one chilling conclusion. To follow the coordinate, humanity would have to send consciousness itself. The philosophical implications tore through global councils and think tanks. Was this an act of exploration or surrender? Was stepping into the alien geometry a journey or an assimilation? What would return, if anything? The threshold keepers warned that accepting the invitation could lead to humanity's annihilation, not through force but through transformation. You do not meet a mind of that scale, one keeper declared, without becoming part of it. But the responders argued that refusing could mean missing the single greatest leap in human history, a leap that might answer every question about life, the universe, and our place within it. Meanwhile, Strange phenomena began to surface among those who had been deeply exposed to the black hole's geometry. Some developed what neurologists called geometric intuition, the ability to solve impossibly complex spatial problems instantly. Others began drawing shapes no one had taught them, shapes that matched structures buried deep in the alien lattice. And in rare cases, individuals reported dreams in which they were already at the coordinate, looking back at Earth from somewhere that wasn't anywhere at all. Then came the anomaly. A team at the South Pole Neutrino Observatory detected a single ultra-high-energy particle arriving from the direction of Sagittarius A. Embedded in its oscillation pattern was a miniature version of the coordinate, but subtly altered. When decoded, it matched precisely the mental pattern of the Lisbon archivist who had lasted 3 hours in the simulation. It was as if the black hole had not only recognized her, but was sending her back. Suddenly, the debate was no longer abstract. The alien geometry wasn't just offering a destination. It was beginning to choose its travelers. In a high-security conference room in Geneva, an uneasy coalition of scientists, philosophers, and policymakers gathered. On the screen before them, the coordinate pulsed gently, its impossible wireframe slowly spinning without moving. "We have to decide," Dr. Sato said quietly. "If we don't go, it may choose someone for us. If we do, we may never be the same." Outside, in the deep black of the galactic center, the black hole waited. Not a monster, not a void, but a door. And with every passing moment, the sense grew that the door was beginning to close. They chose her not because she volunteered, but because the black hole already had. The Lisbon archivist, whose name the public never learned, had been taken to a remote facility carved into the mountains of Chile's Atacama Desert. There, at the highest elevation observatory complex in the world, engineers and neuroscientists worked day and night to prepare the interface. A fusion of quantum entanglement arrays, neural mapping chambers, and an experimental consciousness transmission lattice modeled directly from the alien geometry. No one could agree on what to call it. Some said it was a mind chip. Others whispered the key. To the archivist herself, it was simply the bridge. Outside the facility, the sky stretched impossibly clear. The galactic center hung low, a dense, glowing wound in the heavens. Even without telescopes, you could almost imagine, you could feel its pull. Every night, she would stand alone beneath it, listening for a hum that no one else could hear. The preparation was meticulous because there was no second attempt. Every neuron in her brain would be mapped at Planck-scale resolution, its activity aligned to the black hole's alien coordinate. If even a fraction of her consciousness failed to phase correctly, the transmission would dissolve into meaningless noise. Some saw her as a hero, the first true interstellar traveler. Others saw her as a sacrificial lamb. The archivist herself never once described the mission in terms of heroism. She only said, "It's already opened for me. If I don't step through, it may close forever." The final briefing was short. The scientists spoke in careful, neutral language. Her consciousness would be entangled with a quantum substrate, then projected toward the coordinate, a term that was as much poetry as it was science. There would be no way to monitor her journey in real time. The transmission would leave this universe's causal chain. If she returned at all, it might be seconds later for her, or millions of years in Earth time. Or never. As she lay inside the interface chamber, the alien lattice projected above her in shimmering holographic arcs. The team began the sequence. Slowly, her heartbeat synchronized to the geometric pulse. The air around her felt denser, as though gravity itself were paying attention. She closed her eyes. Her last words before the transmission were not recorded in the official logs. They were whispered to Dr. Akira Sato, who leaned close enough to hear, "If I come back, make sure I remember the sound of rain." The activation sequence began. A low, resonant vibration filled the room, rattling the steel plates underfoot. Around her, the lattice began to shift, folding in on itself, not collapsing, but rotating into dimensions the human eye was never meant to follow. Light bent in impossible ways, touching points that were nowhere near each other in space. The archivist's body remained still, but her neural activity spiked into patterns no human brain had ever produced. The observers described the moment of departure as a slip. 1 second she was there, the next she wasn't, though the chamber itself was unchanged. No flash of light, no cinematic vanishing. Just absence, like a missing word in a sentence. Inside her own perception, the archivist was falling upward through a corridor that had no floor, no ceiling, and no concept of direction. The alien geometry surrounded her not as structures, but as living relationships, shapes that breathed, frequencies that spoke without sound. The coordinate wasn't a point after all, but a state of mutual recognition. It wasn't just that she had found the black hole had found her back. She sensed, not saw, other presences. Not human, not alien in the traditional sense, but minds that seemed made entirely of the geometry itself. They didn't speak so much as fold her into their thinking. For a moment, she feared she would dissolve completely, become a pattern in their infinite lattice. But instead, they showed her something, a space beyond the singularity, where time didn't exist, where matter had no meaning, but where pure structure and consciousness intertwined in endless variation. This was the heart of the black hole, not a crushing endpoint, but a seed. And what it grew was not physical worlds, but new ways for minds to exist. Back on Earth, the facility was silent. The chamber was empty. The instruments recorded nothing unusual, as if the transmission had simply never happened. Weeks passed. Then, in the early hours of an unremarkable Tuesday, the facility's main console lit up with a signal burst from the same ultra-high energy channel through which the altered coordinate had first arrived. It carried a single packet of data, a holographic wireframe slowly rotating. It was her face, mapped in alien geometry. The archivist had crossed. Whether she could return, or had already chosen not to, remained unanswered. But the message was clear. The door was real. And it was now open for more than one traveler.